Welcome to the video on titration of an unknown acid lab, part 3 explained. If you have not watched parts 1 and 2, you should go back and watch those parts. They explain to you how we collect the data during the experiment. In this part of the video, we're going to be analyzing the data. So just to briefly recap, we have done a preliminary titration or indicator titration. And then we did a pH titration. That was the last thing that we did. And we collected some data. So we were aiming to get some sort of graph that looks like this. All right, so here's our data here that we've collected in a spreadsheet. What we want to do is we want to plot, and I'm going to go back to this graph so we can see it. We want to plot the pH on the y-axis and then the volume of base added. Now I want to be clear about this. This volume of NaOH right now is just the volume from the burette reading. But where it says 8.7, that's inaccurate because this was our very first point. That was before we added any base. So this value should actually be 0 milliliters. So how can we get it to be 0 milliliters? Well, what you need to do for this point and for all of the points here is that you need to subtract the initial value. So our initial value will be the 8.7, and so for all of these I want to subtract 8.7 to get the volume of base I actually added. So I'm going to change that to volume of NaOH added, and what I'm going to do here is I'm going to set up the equation where it's equal. I'm going to take this cell, 8.7, and I'm going to subtract from that the initial value, which is also 8.7, and then I'm going to hit enter. And that's going to give me a value of 0. Let me make the font here bigger. Okay, so I want to do that for all of the rest, and instead of typing that in all for each and every point, I'm just going to take my cursor and put it in the bottom right hand corner. When I see the plus sign there, I'm going to go ahead and scroll down. So you may have to do this several times until you get to the bottom. Okay, and so now what I have is the volume of NaOH added. Notice again, my initial should always be 0 if it's the amount that I add. All right, I'm going to insert another column here to the right because what I want to plot is I want this on the x-axis and I want this value on the y-axis. And the way that this program typically reads this sort of thing is that whatever is first is your x and whatever is second is your y. So I'm just going to move this column over so I have my x and my y. Okay, looks great. All right, so I'm going to go ahead and insert, and I'm going to go to chart. So just so we know what we're doing here, we're trying to plot this data. Now this is not the chart I want, so I need to go over to the side here and find the, I believe this would be called the scatter plot. Great, okay, so I get a scatter plot there. And that's what I got going on in this graph here. All right, so as you can see my points, it does look like a pretty decent curve. Maybe I could have reduced the gap in this section, for example, because there's a huge gap here, but that's okay. So I know that my equivalence point has to be somewhere between these. And is I'm going to use the 2 points that are sort of above and below where I think the equivalence point should be sort of halfway in between there, to use that to try and figure out where the equivalence point is on this graph. So if I put my cursor onto the point, it tells me the pH is 6.28 and the volume is 19.81. And here it's the pH is 10.98 and the volume is 20.01. So first let's take a moment to figure out what our volume is. So between 19.81, the volume of the equivalence point, and 20.01, I'm just going to average those out, and my volume should be around 19.91. And so that's the volume at which I had reached the equivalence point. Cool, that's good to know. So my point would be some value in between here. Let me see if I can show you the x-axis as well. Okay. So, so my value should be somewhere on this 20 line or near this 20 line. Now, with that being said, what is that useful for? I can utilize that information in the following calculations. Good for two. This piece of information is good for two things. Now that I know the volume of my equivalence point, I am going to utilize it to calculate the molar mass. So I'm going to just write down here the volume equivalence point equals 19.91. Now, so what I want is the molar mass of this unknown acid, and for molar mass, that's the mass of the acid over its moles. The mass we got from the experiment, we used 3.51 grams, so I can plug that in, but I need to find the moles of the acid. The cool thing is, since this is a 1-to-1 ratio of acid to sodium hydroxide, the moles of acid equals the moles of sodium hydroxide. So I can use this volume that I have here and the molarity of the sodium hydroxide, remember it was a 0.1 molar solution, to calculate the moles. So remember, moles of sodium hydroxide will equal the molarity times the volume. So I go ahead and I type in the volume, but I need it in liters. So, and this right now is in milliliters. So if I convert that to liters, I'm going to have 0.01991 liters. When I multiply this out, I get that the moles of sodium hydroxide is 0.01991, and that means that the moles, since the moles of sodium hydroxide is 0.01991, that will be the moles of the acid. So I can go ahead and type that in here. And then when I do my calculations, I get the molar mass to be about 176. So, and that will be grams per mole. All right. So I'm going to keep that piece of information on the side. So just to recap, I used the equivalence point, which I had to take the average of the 2 points above and below the equivalence point to find the volume at the equivalence point. And then I use that information to solve for the molar mass. Next thing we're going to solve for is the pKa. So remember that for the pKa, you can find that as the pH of the half equivalence point. That means that if it takes about 20 milliliters for me to reach the equivalence point, then at the half equivalence point, it should take about 10 milliliters. And I have a point that's about that right here, and it says that the pH at that point is 4.41. So I find the point that's around 10 for my volume, and the pH is around 4.11. If you didn't have a point at the half equivalence point, then you would then again have to estimate it based on your curve. So let's say, for example, if mine was at 11, I would do an estimation based on the information in my curve. All right, so the pH of the half equivalence point is 4.11. That means my pKa is 4.11. So we now have this information here that the pH and that the molar mass is 176 and the pKa is 4.11. All right, how do I utilize that information? What you're going to need to do is you're going to record that information, of course, in your data, in the appropriate spots in your data. So your pKa should go here. Your molar mass should go here for run 2. I'm going to also have you do a molar mass for run 1. That way you can compare. We didn't do that together, but the process is the same. That way you can compare for run 1 the indicator titration if it's about the same. All right, so you got your molar mass, some number here, which for me would be 176, and then your pKa, which is 4.11. Now, what we are going to do now is at the very bottom, there's a section for you to enter in your pKa and the molar mass in grams per mole. So I'm going to enter in 4.11, and I'm going to enter in 176. And then I'm going to hit check. Okay, this is super important. You go ahead and you hit check, and and it gives you your results right away. You're going to need to take a screenshot of this and attach it to your lab report. Say that again. You need a screenshot of this and attach it to your lab report. Because if you do not get it correct, they will give you 2 more opportunities to get it to correct. So it says that I'm correct. Good job. Okay, awesome. So you can also print this page as well. So either screenshot it or print it, but that needs to go in with your lab report. All right, I'm not going to worry about the printing. So that's how we analyze the data. There are more calculations in here that you have to do, like the Ka. We did do that in our pre-lab, so you can look at that information from the pre-lab. And in terms of the identity of the unknown acid, that it's also, I believe that's also given to you. So ascorbic acid. All right, they're telling you that here. So that's where you would go to figure out the name, and you would write that name down in this section. Final thing, it's really super important that if for some reason between doing the the indicator titration and then the pH titration, if you need to take a pause or a break, do not close down the browser. Okay, so do not close this down until you're completely done with the lab. And the reason for that is if you close it down, what will happen is it may give you another unknown. So the data that you acquired from the preliminary titration may not match the data that you have in the pH titration. All right, so just keep this open until you're completely done. You have this page, you either print it out or screenshot it. I hope you found these videos helpful and have a quality day.